Hello, my name is Ujin Cho, and today I will gonna talking about drift velocity and carrier scattering and mobility. Let me start it with drift velocity. The first thing I learned before was a degenerate semiconductor, which means uh, the semiconductor stopped too much, so semiconductor loses semiconductor properties. And this third picture shows about degenerate semiconductor. Degenerate semiconductors means more this Fermi level is more closer to conduction level. So uh, next thing I learned about is these degenerate semiconductors. There is discrete donor levels mirrored to into a band, so band gap is narrowed, so it called band gap narrowing. The next thing I learned about was current flow in homogeneous semiconductor. This collision means also means scattering, so this scattering is what I'm gonna talk about later. In this section, I learn about drift current equal electron drift current plus Hall's drift current. Also about drift drift current density equal drift current density about electron plus drift current density about Hall. So I can get this equation and erase the electric field, and then we can get conductivity rho equal this equation. Next thing I'm gonna talk about is carrier scattering, and this scattering means collision, which I said before. Like this picture, when there is ionized donor or ionized acceptor, electron and hole is orbit is like this way because of Coulombic force, also expressed as Coulomb scattering. Yeah, that was first scattering, ionized impurity scattering. And next one is phonon scattering. Phonon scattering means that mobile carrier is scattering with lattice. As temperature goes higher, and then uh, this is vibrating more. So yes. Next one is surface roughness scattering. And this scattering means uh, even silicon is not so perfect interface, and it is an imperfect interface. So there, that roughness makes some scattering. And next one is total time of flight. And it can be expressed as tau, and it means time between scattering happen. And we can express it as this equation. And I learned about temperature dependency of mobility and high field effects. And this was important that total time of flight, and there is these things called Matheson's rule. This is what I prepared for today. Thank you for watching my video.